Radiographic testing, or industrial radiography, is a non-destructive testing method of inspecting materials for hidden flaws by using the ability of short-wavelength electromagnetic radiation to penetrate various materials. Either an X-ray machine or a radioactive source, like a 192, Co-60, or in rarer cases CS-137 are used in a X-ray computed tomography machine as a source of photons. Neutron radiographic testing is a variant of radiographic testing which uses neutrons instead of photons to penetrate materials. This can see very different things from X-rays, because neutrons can pass with ease through lead and steel but are stopped by plastics, water and oils. Since the amount of radiation emerging from the opposite side of the material can be detected and measured, variations in this amount of radiation are used to determine thickness or composition of material. Penetrating radiations are those restricted to that part of the electromagnetic spectrum of wavelength less than about 10 nanometers. Inspection of welds: the beam of radiation must be directed to the middle of the section under examination and must be normal to the material's surface at that point, except in special techniques where known defects are best revealed by a different alignment of the beam. The length of weld under examination for each exposure shall be such that the thickness of the material at the diagnostic extremities, measured in the direction of the incident beam, does not exceed the actual thickness at that point by more than 6%. The specimen to be inspected is placed between the source of radiation and the detecting device, usually the film in a light tight holder or cassette, and the radiation is allowed to penetrate the part for the required length of time to be adequately recorded. The result is a two-dimensional projection of the part onto the film, producing a latent image of varying densities according to the amount of radiation reaching each area. It is known as a radiograph, as distinct from a photograph produced by light. Because film is cumulative in its response, relatively weak radiation can be detected by prolonging the exposure until the film can record an image that will be visible after development. The radiograph is examined as a negative, without printing as a positive as in photography. This is because, in printing, some of the detail is always lost and no useful purpose is served. Before commencing a radiographic examination, it is always advisable to examine the component with one's own eyes, to eliminate any possible external defects. If the surface of a weld is too irregular, it may be desirable to grind it to obtain a smooth finish, but this is likely to be limited to those cases in which the surface irregularities may make detecting internal defects difficult. After this visual examination, the operator will have a clear idea of the possibilities of access to the two faces of the weld, which is important both for the setting up of the equipment and for the choice of the most appropriate technique. Defects such as delaminations and planar cracks are difficult to detect using radiography, particularly to the untrained eye. Without overlooking the negatives of radiographic inspection, radiography does hold many significant benefits over ultrasonics, particularly insomuch that as a picture is produced, more accurate identification of the defect can be made, and by more interpreters. Very important as most construction standards permit some level of defect acceptance, depending on the type and size of the defect. To the trained radiographer, subtle variations in visible film density provide the technician the ability to not only accurately locate a defect, but identify its type, size and location. An interpretation that can be physically reviewed and confirmed by others, possibly eliminating the need for expensive and unnecessary repairs. Safety: industrial radiography appears to have one of the worst safety profiles of the radiation professions, possibly because there are many operators using strong gamma sources in remote sites with little supervision when compared with workers within the nuclear industry or within hospitals. References: Standards, International Organization for Standardization, ISO 4993, Steel and Iron Castings, Radiographic Inspection, ISO 5579, Non-destructive Testing, Radiographic Examination of Metallic Materials by X and Gamma Rays, Basic Rules, ISO 10675-1, Non-destructive Testing of Welds, Acceptance Levels for Radiographic Testing, Part 1, Steel, Nickel, Titanium and Their Alloys, ISO 11699-1, Non-destructive testing, industrial radiographic films, Part 1, classification of film systems for industrial radiography, ISO 11699-2, non-destructive testing, industrial radiographic films, Part 2, control of film processing by means of reference values, ISO 14096-1, non-destructive testing, qualification of radiographic film digitization systems, Part 1, definitions, quantitative measurements of image quality parameters, standard reference film and qualitative control, ISO 14096-2, non-destructive testing, qualification of radiographic film digitization systems, Part 2, minimum requirements, ISO 17636-1, non-destructive testing of welds. Radiographic testing. X and gamma ray techniques with film, ISO 17636-2, non-destructive testing of welds. Radiographic testing. X and gamma ray techniques with digital detectors, ISO 19232, non-destructive testing, image quality of radiographs, European Committee for Standardization, EN 444, non-destructive testing. General principles for the radiographic examination of metallic materials using X-rays and gamma rays, EN 462-1, non-destructive testing, image quality of radiographs, Part 1, image quality indicators, determination of image quality value, EN 462-2, non-destructive testing, image quality of radiographs, Part 2, image quality indicators determination of image quality value, EN 462-3, non-destructive testing, image quality of radiograms, Part 3, image quality classes for ferrous metals, EN 462-4, non-destructive testing, image quality of radiographs, Part 4, experimental evaluation of image quality values and image quality tables, EN 462-5, non-destructive testing, image quality of radiographs, Part 5, image quality of indicators, determination of image unsharpness value, EN 584-1, non-destructive testing, industrial radiographic film, Part 1, classification of film systems for industrial radiography, EN 584-2, non-destructive testing, industrial radiographic film, Part 2, control of film processing by means of reference values, EN 1330-3, non-destructive testing, terminology, Part 3, terms used in industrial radiographic testing, EN 2002-21, aerospace series, metallic materials. Test methods, Part 21, radiographic testing of castings, EN 10246-10, non-destructive testing of steel tubes, Part 10, radiographic testing of the weld seam of automatic fusion arc welded steel tubes for the detection of imperfections, EN 12517-1, non-destructive testing of welds, Part 1, evaluation of welded joints in steel, nickel, titanium and their alloys by radiography, acceptance levels, EN 12517-2, non-destructive testing of welds, Part 2, evaluation of welded joints in aluminium and its alloys by radiography, acceptance levels, EN 12679, non-destructive testing, determination of the size of industrial radiographic sources, radiographic method, EN 12681, founding, radiographic examination, EN 13068, non-destructive testing, radioscopic testing, EN 14096, non-destructive testing, qualification of radiographic film digitization systems, EN 14784-1, non-destructive testing, industrial computed radiography with storage phosphor-imaging plates, Part 1, classification of systems, EN 14584-2, non-destructive testing, industrial computed radiography with storage phosphor-imaging plates, Part 2, general principles for testing of metallic materials using X-rays and gamma rays, ASTM International, ASTM E94, Standard Guide for Radiographic Examination, ASTM E155, Standard Reference Radiographs for Inspection of Aluminum and Magnesium Castings, ASTM E592, Standard Guide to Obtainable ASTM Equivalent Pentameter Sensitivity for Radiography of Steel Plates 1/4 to 2 inches, 6 to 51 mm thick with X-rays and 1 to 6 inches, 25 to 152 mm thick with cobalt 60, ASTM E747, Standard Practice for Design, Manufacture and Material Grouping Classification of Wire Image Quality Indicators used for Radiology, ASTM E801, Standard Practice for Controlling Quality of Radiological Examination of Electronic Devices, ASTM E1030, Standard Test Method for Radiographic Examination of Metallic Castings, ASTM E1032, Standard Test Method for Radiographic Examination of Weldments, ASTM 1161, Standard Practice for Radiologic Examination of Semiconductors and Electronic Components, ASTM E1648, Standard Reference Radiographs for Examination of Aluminum Fusion Wells, ASTM E1735, Standard Test Method for Determining Relative Image Quality of Industrial Radiographic Film Exposed to X radiation from 4 to 25 MeV, ASTM E1815, Standard Test Method for Classification of Film Systems for Industrial Radiography, ASTM E1817, Standard Practice for Controlling Quality of Radiological Examination by Using Representative Quality Indicators, ASTM E2104, Standard Practice for Radiographic Examination of Advanced Aero and Turbine Materials and Components, American Society of Mechanical Engineers, BPVC Section V, Non-Destructive Examination, Article 2 Radiographic Examination, American Petroleum Institute, API 1104, Welding of Pipelines and Related Facilities, 11.1 Radiographic Test Methods. See also, Radiography.